One thing that tends to happen in most every class is at the beginning of the semester, everything is laid out. We're going to spend this amount of time on this, we're going to spend this amount of time on this, etc. And it almost never works out that way. Something happens. Students need more time to go over a certain topic. Something just didn't make sense. Everybody screws up a test, whatever it is, but something happens. I'm trying the best I can to make sure that doesn't happen this year, okay? And the way that I've done that is right now we're actually on a good pace. We've gone through the first 11 chapters of this book. That's pretty damn good, all right? What we've got left is basically the information in section 3 and the information in section 4, all right? And then what I wanted to do was maybe the last day of class or whatever, talk about how to enhance the user interface and talk about some of this other stuff. And I was going to go over files and talk about text files, and we can do that, and talk about binary files. The problem is files themselves are not used that often in programs. Almost always, rather than using files, you use databases. It just makes more sense to do it. And there's a lot of better, good software out there, etc. Well, I'm not going to jump into databases because in this book, it assumes that when you get into the database section, that you've already gone through the object-oriented programming section, because they start talking about classes and stuff. And if you haven't talked about classes, that's not going to make a hell of a lot of sense. So what I've decided that we're going to do starting today is I am actually going to lecture on Chapter 12. Now, my guess is few, if any of you, have read this. So what I would suggest is just watch. Because what I'd like to start doing tomorrow is we are going to build an application as a class, and it's going to be an object-oriented application. And we're going to do it first in a console format so we can concentrate just on the code. I don't want you to get caught up in the GUI part. Then we'll take the same thing that we create, and instead of having it run as a console app, we'll have it run as a GUI app. Hopefully that makes sense to everybody. All right? So as said, I'm going to jump into Chapter 12, but before I do, I'm going to lecture on Chapter 12. I'm not going to go over Chapter 13 today, but probably one day this week I will. You will be tested on Chapter 12. You'll basically not be tested at all on Chapter 13. I'm not going to go over the written test or anything. We will go over the written test in a week or so for Chapter 12. All right? We will go over Chapter 14 because that's on inheritance, and that's an important topic. We will also go over a little bit of Chapter 15 and 16. But the bottom line is this: your understanding of object-oriented programming will be maximized if you concentrate on the information in Chapters 12 and 14. And I don't at all mean to say the other stuff isn't important, but the most important is the stuff in 12 and 14. So with that said, I'm going to jump into Chapter 12. I'm going to take my time. Believe it or not, even though it's one chapter, we may or may not finish this today. It starts on 362 and it goes to 406, which means it's more than 40 pages. And there are a boatload of code examples and other kinds of examples in here. This is hinky, the way they do this. And when we get to the Java and Android stuff, some of it is done virtually the same. Some of it is done totally different. That's one of the things that distinguishes different languages from one another. All right. So when you look at this, we start with about an 8 or 9 page introduction to classes. So it's a lot of terminology and some very simplistic examples. Then we get about 12 or 13 pages where they show you how to create a class. All right, and they talk about the different components of a class. Then you've got about 8 or 9 more pages, 7, 8, whatever it is, where they go over an actual completed class. And actually, in this example, there's 2 or 3 classes. But one of the classes that's in here, they aren't even going to go over until the database section. So don't worry about that. All right. Then, as it says, even more skills for completing a class. And they'll show you some of the shortcuts that exist in here. And we'll talk about those. Finally, they get into talking about how to browse, diagram, and display and edit classes. So all the stuff up to page 402. So all the stuff except for the last, I don't know, 4 or 5 pages of the chapter are all on classes. Then at the end of the chapter, they talk about structures. All right? And they'll even say how close structures are to classes, so they'll compare and contrast them. So what my hope is if something doesn't make sense here, you will ask. Now, I'm not going to assume that if you don't ask, oh yeah, you get it. You didn't ask questions, because until you work with this stuff, it won't make a lot of sense. So rather than me giving examples today, I'm going to use the examples that are in the book, and then we'll start doing and going through our own examples tomorrow. There are tons of good YouTube videos out there. There are tons of good sources out there. I mean, you can go out to docs.microsoft.com and find examples, etc. We'll write our own tomorrow. So the idea is you don't go through this one chapter and boom, now you're an expert on classes. So you totally understand object orientation. All right? But you've been introduced to it. You'll have written some programs that go through it. All right? You will have an understanding of it. Now, the way that I usually explain this, and it's going to lead right into this, is imagine that right across from Rankin here, you know, there's that one house in there, and then there's a bunch of open land. Let's just assume there's 100 acres of land in there. All right? And someone buys that. So they bought 100 acres. They'd like to put 100 houses on there, but and each one hold an acre. But the problem is, then where are you putting roads, sewer, etc.? So they decide they're going to put in about 75 houses. Okay? They put a road in there, etc. You've seen this before when neighborhoods go in where there previously wasn't a neighborhood. All right? And the builder comes in and they decide, they come in and they've got 5 different house plans. All right? 1 or 2 of them are 2-story, the other ones are ranches. Some of them are sided, some of them are not. Some of them have 3 bedrooms, some of them have 4 or 5 bedrooms, etc. You get the idea. All right? So if we said that the builder comes in with 5 different house plans, each one of those house plans would be a class. Because a house plan is like a blueprint, and that's what a class is. A class is a blueprint for how objects you make of classes are going to look. So, you know, the builder could come in and build 2 houses right next to one another that had the same house plan. One could be sided and one painted. All right, one could have a certain kind of door or a certain kind of windows, but they're the same house. Does that make sense to people? All right. So classes are blueprints. Each instance of the class is an object. So what does that have to do with anything? Well, I mean, so far with what we've been doing in our programs, and I've mentioned this kind of thing to you. All right, I'm just going to go back to my card demo for a second. But when we came in here and put this out there, now just imagine for a second, I'm not going to save this, but just imagine that I came out here and I added a button right there. Let's just say I want to set it up. I want to make this big, long, hairy button here. And I'm going to call it button clear, etc. And it's going to clear everything out and set it back to its defaults. You with me? All right. What I just did was I created a button object. And a button object is a member of the button class. So when we go over here, and you've seen this before, when we go over here and we click on this lightning bolt, these are all the methods that a button object, because it's part of the button class, these are all the different methods that that object can run by default. Now we can call our own methods from these. We've done that before. We've taken the code that had gone into a click event and put it into our own method. That's totally fine to do. So these are the methods that that button has inherently. On the other hand, if I go back to here, these are what are called the properties of the button. So if I click on the button here, and you'll notice, all right, that I've got button 1 here, and I've got, for example, let's see, let's look for, there's the size property, 733 by 42, 733 pixels wide, 42 pixels tall. If I change that from 733 to 233, you immediately see the change. So what I've done is I've used the properties window to go in and change the property of a button object. All right? And there's all sorts of other ones. I mean, I just want to give you a real life example of something that we've actually been doing. Now, in a real life project, so imagine that here, that let's just assume I'm the supervisor. All right? And all 7 of you have been hired in, and you're all going to be programmers. Okay? And we're going to build some kind of a payroll system for this company that we all work for. We could buy it, but we decided that anything out of the box isn't good enough. We're going to build it ourselves. And there's a lot of different stuff. There's figuring out taxes. There's figuring out deductions. There's figuring out like IRAs, etc. So what we decide is each one of you is going to have your own job to do in here. And so, maybe Gabriel is going to do deductions, all right, etc., that kind of thing. And then we decide, well, now we've got all this stuff, but we need some kind of a GUI for it. So Aaron's going to do the GUI. Okay? Well, why am I telling you this? Because what we're starting to do is we're starting to break this up into different jobs. And when you get a project of any size, that typically is what happens. I may have mentioned this to you guys. I'm sure I did to you guys last semester. But in my first programming job, I worked on a telephony system. It was 5 million lines of code, literally. And I was responsible for about 10,000 of those lines. All right, that was the joke. We were just a bug on the windshield. And then later, no, it wasn't that. Pardon my French for swearing a little, but no, we were the crap that came out of the bug that was on the windshield. Because we didn't even come up to bug status. All right. And they wanted it like that because people were constantly coming in and out of that company. They'd quit to go to at that time, there were a lot of other telephony companies. They'd quit because they got a better offer from another company. They didn't want to give one person the responsibility of 1 million lines of code because what if that person left? All right. So what I'm getting to here is this idea. They talk here about a multi-layered architecture. Let me make this a little, well, I guess I can't. But this is it. So far, the only thing that we've really been concerned with has been the presentation layer. All right, we've delved into the middle layer. So when we created, for example, a program, and we created a program for a payroll program, all right, we did it both in GUI format and in console format. But whether it was a GUI or a console, that was our presentation layer. All right, and then we came up with business type of stuff, such as, if you remember, we said a person can work between 0 and 84 hours. We said a person can make between 0 and $99.99. Those are business rules. All right. What's a business rule here? Technically, if somebody walks in off the street here, all right, and sits down someday and it's not one of their shadow attack days, I'm supposed to walk up to them, say, "What are you doing here?" And if they say, "I don't know, I just was walking by and the door was open, I came in, thought I'd sit in and see what you're doing," I'm supposed to ask the person to leave. And if they don't leave, I'm supposed to let Mr. Corrigan know. If they still won't leave, I'm supposed to let Patrick know, or really let the security guy here know. It probably wouldn't happen anyway, but you get the idea. Every company has business rules. With what we've been doing thus far, we've been just coding the business rules right into our program. But typically what you do is you take your business rules and you create what are called business classes. So you have classes that handle different entities or different parts of the company. And that's all fine. And that's what we are going to do soon. But we're still going to have a problem. And the problem is we don't have a database layer. So that database layer, really, I don't like the way they put that. I wouldn't have even put database layer there. I would have put down persistent layer. Because it could either be a database layer or it could be a file layer if you were using regular files, text files, binary files, whatever. But if you wanted your data to persist. So the problem we're still going to have until we get into the database section is unless we've got a method to save this to something, when we get done and we get out of the program and get back in, all the data that we put in previously doesn't exist anymore. All right. So that database layer that they talk about right there, that's for persistence. Now, one thing that we, when the class that you used to have after this one, don't anymore, but you used to have, was a follow-on to this class. We went over a language called ASP.NET, which is kind of C# for the web, for lack of better words. It kind of is. That's taking something that's fairly complex and putting it into a sentence. All right? But when we worked with that stuff, we worked with what was called a model view controller architecture, which you may have or may never have heard of. But to just tell you what it is, because I want you to hear these terms, it's like if I'm here and I decide I'm going out to Amazon.com. All right? What that did, when I put that in, okay, I typed in Amazon.com, I hit enter. On Amazon's side of it, so on the server side, what happened was Amazon figured out which server should handle my request. All right? And that server basically brought up this screen and then sent that information back to me. All right? That's how it works. So what happens is the view and model view controller is what you see on your screen. It's what we're calling the presentation layer now. All right? And the model is what we're calling the database layer. In fact, we're not even calling it that. We're calling the model this middle layer right here. But normally in a model view controller architecture, the model has both the business classes and the database that you use to incorporate the business classes. All right? And the controller, which you don't see here in a model view controller architecture, it's kind of the supervisor. So in other words, if I go here and I say that I want to see Kindle books. So if I look up here and I click the Kindle books, it probably is going out and calling another server, and that server is bringing me back information regarding Kindle books. All right? So we're not using a model view controller architecture, an MVC, but I'm bringing it up because you hear about that a lot. I have gone to job interviews already when they said, okay, you've got, in a paragraph or in a few sentences, go over what model view controller is. What we're using as opposed to this is what's typically referred to as a three-layered type of architecture. Presentation, middle, and database. All right? The presentation layer is the only one the user of the program, the person running it, ever sees. Okay? The database layer is where all of your information is stored so it can persist. And the middle layer has got basically the way that your database layer is able to present the information to the presentation layer. Now that was long, but I hope it made at least some sense to you. All right? I'm not going to read what they say because it isn't exactly the same thing. But you can look at the way that they present it in here as well. All right? All right. And it says the members that you can define within a class. So right now we're going to talk about properties. We're going to talk about methods. And we're going to talk about events. And guess what? I just showed you what properties were. They're what's in the properties window. And virtually every property that you see in that properties window, you can manipulate either either using code or using the properties window. And if you say, I don't get it, and I would beg to differ with you, because yes, you do. In this example that I just went over with you, all right, when I went over it and I showed you this code at the end, this is a good example. Here, I am setting the visible property in code. Could I have gone in to the properties window and set it? The answer is yes. But when you set something in the properties window, it's a set it and forget it. When you set it in code, you can set it, and then whenever you want to or need to, you can reset it. Does that make sense to everyone? All right. So those are properties. So if I said, okay, give me use something that I could totally identify with. Give me a properties list. Okay, human being, properties, height, weight, eye color, hair color, gender. They're not behaviors. Behaviors are methods. So, for a human being, eating, drinking, sleeping, etc. Sometimes when you look at a property and you look at a method, you don't know if something is a property or if it's a method. If it's a method, it has parentheses after it. If it's a property, it doesn't. All right? And then there's events. What are events? Well, they're the way that the system responds to stuff that happens. We've looked at the button click event. That's the one we've been using. Now in this last test that you had, you looked at the index changed event for your indexes for your drop downs. Those were events. All right. Now there are hundreds, if not thousands, of built-in .NET framework classes. They just exist out there. And guess what? You've used some of them. You've used the console class before, whether you realize it or not. What is one thing we've done in all our console apps? We put in using system.console. System is basically what's known as a namespace, and console is one of the classes inside of the system namespace. And there are loads of them. All right, what's a constructor? Well, when you go in and you create your own object, what gets called automatically is what's referred to as a constructor. It automatically gets called. You say, what if I don't make one? Guess what? Then C# makes one for you. What does it do? Absolutely nothing. It only does what you tell it to do. But the constructor is basically where you initialize things. You know how we've been taking our global variables and we've been creating them and initializing them outside of everything? We're going to still create them outside of everything, but we're not going to initialize them there. We're going to initialize them when we create an object of that type. Why? Why would we do that? Well, imagine a person. And I said height, weight, eye color, hair color. Okay? Then I go and start creating people. I say person Christopher equals new person. Now I can give it an eye color, a hair color, a height, and a weight. Now I create another one. And I say person James equals new person. Probably going to have a different height, probably going to have a different weight, etc. All right? So that's what we're getting into now. And that's what you do inside of the constructor. So that's not only C# classes, but as it says, it's classes that you design yourself. Also have properties, methods, constructors, and events. The difference is they only have the stuff you give it. All right, so for instance, I'm not trying to be funny here, but if I did a person, and I said that person can eat, that person can drink, and that person can sleep. Well, unless I build in swallowing into the eating class, they can't swallow. So an object only has the abilities that you give it, is what I'm saying. All right, and no more, and no less. All right. So we're going to look at one of these in just a minute. But they talk about a few words in here too. And I think I've used this example. I'm going to give you two quick ones. All right. So I come in here and I type in 89 and I hit, let's see, that button right there. Okay? I don't even know what that did, but it did some kind of a calculation. Would you agree with that? Okay, internally, how did that calculator just do that? How did it do that? Can somebody tell me? Because I don't have a flaming clue. There's something wired into this, right, that did it. Okay? So what I see is the interface right here. So I know that if I clear something out and I type in 56 times 12 and I didn't know what that was and I click equal, it says 672. My interface was clicking those buttons and then the equal sign. And the final interface is the answer. The implementation is what happened to take the 56, multiply it by 12, and give me 672. All right? So the interface is what you show people. The implementation is the code behind it that makes the interface do what it does. And so there's this word here, encapsulation. And it says it lets you hide or encapsulate some of the data in the operations while exposing others. So what if tomorrow somebody came up with an even faster way to do multiplication than what we just did? All right, it was something with artificial intelligence, and it could figure out, based on you hovering or doing whatever, it could do it even faster. If my interface didn't change, but the implementation changed, I wouldn't know that. Does that make sense? All right. So this is your first foray into this. So we're going to create a class called product. And the product is going to have different things in it. All right. It's going to have 3 members. It's going to have a code, and that's going to be a string that identifies each product. So for instance, let's say that in Amazon, that each book that's in there has got a number that's associated with it. So I find a book on creating a website, and I click on it, and it says the code is book-12345. That would be the code. All right. Then a description. Well, you see that usually, like if you go out to Amazon or whatever, and it gives you a little description of what the book's about. That's also a string. Then a price. And we're not talking here about, well, what about a sale price? No, I don't care. We're keeping this real simple. We're saying that every product has these 3 fields in it. So these are the 3 properties of any product. Any product will have a code, a description, and a price. And any product will be able to display itself. So as it says, it'll return a string that has the code, the description, and the price in a displayable format. It might just say book-123456, or it might have that followed by the title. It doesn't matter. But that's the method. There's just one method. And it has 2 different constructors. What does that mean? That means that when we create a new product, we can either create a new product and not pass it in nothing. And if we pass it in nothing, anybody want to take a guess here? It still creates a code and a description and a price. Anybody want to guess what value is for the code? What value is given? Anybody want to take a guess? It's the empty string. Double quote, double quote. Same thing for the description. Anybody want to guess what its default price would be? 0. And if it's a decimal value, it'd be 0.00M. So if we create a new product, hey, we just created a new product. Really? What's it called? I don't know yet. What does it do? I don't know yet. How much does it cost? I don't know yet. Well, you don't know much, do you? No, but I could create it. All it has is a name. That's it. All right. Or when we create a product, we can give it a code, and we can give it a description, and we can give it a price. So when we create this product, we must either give it nothing when we call the constructor, or we must give it 3 pieces of information when we call the constructor. Does that make sense to people? So when you look at this, this is their definition. In this chapter, we're concerned with these three: the property, the method, and the constructor. All right. In the next chapter, we get into delegates and events in more detail, and in later chapters, indexers, etc. All right. So this is their definitions. An object is a self-contained unit of code that contains properties, methods, etc. for an object. All right. A class is the blueprint. The object is the instance of the class. When you create an object based off of a class, it's called instancing the class, or it is the act of instantiation, one or the other. Encapsulation is also known as data hiding. As it says, it allows you to say, hey, I'm going to show you this much of the interface, but the rest of it I'm going to hide, and it's only going to be available to me through my implementation. All right. And although a class can have many different types of members, most classes you create will just have properties, methods, and constructors. So most classes that you create won't have this stuff at the bottom. Delegates, events, etc. It's not that they can't. It's just that typically they don't. And when you first start doing this, all right, we're going to keep it simple. All right. So now we talked about that. Next, so let's go over this, and then we'll take another break. This is the code, as it says, for the product class. Let's look at it, and then we'll come back. It's going to look a little weird compared to the stuff we've done so far. And it's not very small either. So I can't show it all on one screen. All right. But notice, public class product. Everybody see this? All right. So boom. There's our public class product. Now, if we look at, for example, this is my code from the test. What do we have at the top of the screen? All right. We've got public partial class. All right. And all of the difference between a class and a partial class is when you have a partial class, you can combine it with another partial class to make a full class. If you say, I don't get that, don't worry about it. But we've got a class in here right now, is what I'm telling you. All right. Albeit a partial one rather than a full one. Now, these fields that are here, in some programming languages, they don't call them fields as they do here. They call them class variables. What that means is every time you create an object of the product class, it will have a code, a description, and a price. Even if they're equal to the empty set and 0, they still all have a code, they still have a description, they still have a price. Again, it's like if I created a person class and gave it 4 fields: height, weight, eye color, hair color. That would mean all of you, when you were born, is, well, what about a bald baby? You put something down. I don't know. That's not even important, to be honest with you. But these are, every single product that we create must have these fields. These things here, if you look on the screen right there, and here, those are the 2 constructors. So typically at the top of the program, you put in your fields or your class variables, and you follow that with your constructor. Now, I'm going to ask you a question. You're going to think it's a trick. It's not. Look at this line right here, and this line right here. What's the difference between those 2 lines? It's not a trick. What's the difference between those 2 lines? That's right. So this is typically what's called a parameterless constructor. And it means you're not passing anything into it. All right? So it does nothing, which by default means, and you're going to see this in a future page, it sets everything to their default values. The default value for strings are the empty string. The default value for a decimal variable is 0.00L. So that's what this one is going to do. If we call it and pass it in these 3 things, then whatever code we pass in is this dot code means that one. This dot description is that one. this dot price is that one. Do you need to use the word this? This is, and what I'm about to tell you sounds strange. Depends on the language you're using. Believe it or not, in C#, no, you don't have to. Depending on how you set it up in Java, sometimes you have to. All right, I'm going to recommend that if you use the same name here, this name here, as the name that you're using here, if you do it like that, that you use the word this. Now, do you notice something? You notice that when you use the word this, and even if you didn't, do you see how those are capitalized? That's still these. And that distinguishes, because if you said code equal code, you would confuse the system. This is what you pass in. So imagine, so if I come in and I say product P1, product 1, equals new product, paren, just like that. Now the code is this, double quote, double quote. The description is double quote, and the price is 0.00M. That should make sense to you. Now I create another product, and I say product P2 equals new product, and I say widget does everything. I'm making that up. And it's $5. Now for product 2, the code is widget. The description is does everything. And the price is $5. Does that make sense to you? All right. Now, there are two constructors. They look exactly the same. And as Nicholas just said, and he's right, the difference is the second one has stuff in the parentheses. The stuff that's in the parentheses is what's referred to as the signature for the method. It's what distinguishes this one from this one. So I can have two different methods with the same name as long as their signatures are different. That's called overloading a method. We're making it do double duty. We could even come up with another one where maybe we have a code, so we would say in their string code, maybe we have a description, we've got string description, but we don't have a price yet. So we could come up with another one. And since there are three things, all right, we could put in, the names are irrelevant to the computer. The computer looks at this as, okay, no parameters, string, decimal. It does not look at the names. It doesn't care. All right? And I want to just say one more thing, and that is, when we looked at this, when I just put this in here, this is how you typically instantiate or create these. You would say product P1 equals new product. It looks a little weird until you get used to it, but this is the name of the class. This is the name of the object. This is the instantiation. So product is the name of the class. P1 is the name of the object we're making of that type of class. And then we're instantiating. We're saying it's equal to a new product. And it's smart enough to know, oh, you're calling the parameterless constructor, so do this. So set it equal to the default values. In the other one, I'm not going to put it up again. It was smart enough to know, oh, first one is a code, that widget. The second one is the description, does everything. The third one is the price, $5. All right? And I mean, if you can at least understand that, you're on your way to understanding it. So I'm going to go through the rest of this page here, and then we're taking a break. So what you can do when you do these, notice we've got public string code, get set, public string description, get set, public decimal price get set. And it looks a little weird. These three fields, these are what are called getters and setters. All right? And you guys looked a little bit at these last semester, but not really very much. All right? So I always found it interesting. The first day I walked into class and I got my roster last semester, there were 2 Gabriels. All right? But what if I was constantly, getting deluged by questions from both of them? And, they walked in there the first day and I said, the first Gabriel, "Hi, what's your name?" And he said, "Gabriel." That's a getter, right? He's giving me information. Now, then the other Gabriel walks in and I said, "Hi, what's your name?" And he says, "Gabriel." And I said, that's too confusing. You're just Gabe from now on. That's a setter, because I am changing something. I'm saying from now on, you're Gabriel, you're Gabe. Do you understand the difference? I mean, because, one of the examples that people use, and I think it stinks as an example, kind of the one I just gave you. But when a baby is born, typically, it's given a name, right? And that's really, unless they get married or whatever, or change their name. But, not trying to sound sexist, but for most men, that's the name you're going to have for the rest of your life. All right? So there's only one time it's set. But you are probably asked hundreds of times during your life when you meet different people, when you introduce yourself, they may say, "Hi, what's your name?" All right? Well, you're not going to say, "Oh, gee, today I'm going to be Bob." All right? So what this does, is this says anytime that code appears on the right-hand side of an equal sign, when it appears on the right-hand side of an equal sign, anytime that happens, all right, it's going to call this setter. Anytime it appears on the left-hand side of an equal sign, it's going to call this getter. Not only that, so I'm just going to put this first one up there so you see it. In fact, it is right here. If this is all you're doing in here, if you're doing it like this, and you're not doing anything special, you can write it as public string code get set. Just like that. That's a shortcut for what they have up there right now. Now, what if I wanted to do something, like what if I wanted to make sure that the price, for example, the price was greater than 0. You couldn't have a negative price. So then I couldn't use that shortcut that I just showed you. But if it looks like this, you typically see it written like that. All right, and there's even shortcuts to have Visual Studio put that in for you automatically. We're going to look at those after the break. All right. So notice here, code, description. So these fields, lowercase. When you use them in getters and setters, uppercase. See that? Not my rule, and it's unique to this language, from the languages that I know at least. And then this is the other method. This looks like something you've already written, really, except we've typically been saying like private, static, or whatever. But this is public, so it's going to return a string, and it's going to be passed in a string. And what's it returning? That code. So where it says return code, that's going to call this right there. It's going to call that getter. All right. Oops. And then it's going to add a separator. It could be a comma, could be a blank space, could be something else. Then it's going to call the price, all right, which is right here, but it's going to convert it to a string because remember it's a decimal, and it's going to print it with currency format followed by the separator, followed by whatever the description is. Now, I have no idea if that made sense to you or not. All right. So we're going to take another break, and it's 10:18. So let's come in. Let's take 15 minutes, and then we'll come back and pick it up on here. Like I said, I'm in no hurry to get through this. So if we get through part of it today and we continue on tomorrow and start going through an example tomorrow, that's just fine with me. All right. So again, we'll start up again in 15 minutes.